So we started by guessing for the most part. I call it identities. Your book calls it special something. Doesn't call anything, but you'll get the point when I do this. So the first one is called sum of squares. Suppose you just have two terms and you have a squared plus b squared. Square here, square there, yes. And if you have an expression of this sort, you just have to stop because you cannot factor it using real numbers. Good. So this is what we call a prime expression. Just like a prime number, you cannot factor a prime number. The only factor that you have is itself and number one. The same argument here. But if you have difference of squares, a squared minus b squared, mind you, you've got to have only two terms. If you can write it as a squared minus b squared, then the factored version would be a plus b times a minus b. Good. So the key here is you should try and write it in terms of squares. If you have sum of squares, the board mission, nothing could be done, it's prime. If you can come up with difference of squares, then it is simply a plus b times a minus b. Unlike sum of squares, we can factor sum of cubes. Sum of cubes is simply a plus b times a squared minus ab plus b squared. You can put this in your formula sheet or cheat sheet. Don't have to memorize. And if you have a cubed minus b cubed, it is a minus b, a squared plus ab plus b squared. There's an easier way to remember. You recognize the concept. What's that?
The subtraction and like the addition.
So they flip, right? So if this is plus here, you've got plus there, becomes minus. Minus here, minus there, becomes plus. Okay. Easier way to remember. In this class, you don't have to memorize, you can just put that in your cheat sheet. So if you have sum of squares, there's nothing you could do, leave it as is. Difference of squares, if you can write it, you can factor it in this form, a plus b times a minus b. If you have sum of cubes, in other words, a cube term, perfect cube plus a perfect cube minus a perfect cube, you can factor it this way. So the goal is to simply identify a and b and plug it in that formula. Does that make sense? X squared minus 16. We already have a perfect square, correct? We call it x squared. Is 16 a perfect square? Yes. I can write 16 as 4 squared. Yes. And you can see that I threw in parentheses the moment I recognized the exponents. So make sure you put the parentheses. So what is A and what is B? A is X and B is 4. So we know A, we know B, we just have to go ahead and put it in that formula. So A plus B, X plus 4, A minus B, X minus 4. Good. How do you verify your answer? FOIL it. But if you're confident in identifying A and B, and with that formula, you should be confident about your answer. X squared is a perfect square to begin with. So X squared. The only way we would be able to factor this is if 81 turns out to be a perfect square. Is 81 a perfect square? Yes. 9 squared. What is A? X. And what is B? 9. And what does the formula state? X plus 9 times X minus 9. Good. There are only 2 terms. Well, is this a monomial, binomial, or trinomial, or polynomial? It is a polynomial. It's a binomial. What's the degree? 2. Okay. Perfect square, perfect square. Yes. Now, as long as the 2 numbers end up being perfect squares, I can do some manipulation and find A and B. Like what?
Did you just say some monomial?
Binomial.
Oh, okay.
2 terms.
But you said one. Okay, go ahead.
So 4, I can write it as 2 squared and X squared, so times minus 9, 3 squared times X squared. Yes. Since we have, oh, Y squared, sorry, bad man. Since we have identical powers, I can combine the 2 and the X. So I can write this as 2X squared. Yes. What about here?
Negative 3y squared.
Negative 3y squared. What is A? We have square minus square. What is A? And what is B? And what is the formula now that it's gone?
Oh, A squared plus
A plus B, 2x plus 3y times A minus B, 2x minus 3y. Good. A plus B times A minus B. So 1 is a perfect square. 1 squared. Putting the parentheses will help recognize A and B easily. 36 is a perfect square. 6 squared, 36. Y squared. The powers are identical, so I can combine this x and the y. What is A?
1,
What is B?
1,
So what does the formula state?
1 plus 6y, 1 minus 6y.
1 plus 6y times 1 minus 6y. A plus B times A minus B. Good. Let's give that one a try. Is 49 a perfect square?
Yes.
Yes. 7 squared is 49. So 7 squared times x squared is 25 a perfect square. Yes. 5 squared times y squared. The powers are identical, so I can combine the two together. Same over here, the powers are identical, so I can combine the two together. So 5 times y squared. What is A? What is B? 5y. What does the formula state? The formula states if we have a squared minus b squared, it is simply 7x plus 5y times 7x minus 5y, a plus b times a minus b. Yes. How do we verify the answer? FOIL. You can always FOIL. Okay. Number 6. This is what some of you did. At least you understood part of the stuff. So 49 is a perfect square. So you wrote that term as 7x squared. Yes. From that point onward, this is what some of you did. 1 plus 7x times 1 minus 7x. Yes, that's not correct. Because a plus b times a minus b is a squared minus b squared. Yes, that's what we've been doing. So I want you to go back to the beginning of 5.6 from 20 minutes ago. What did I write first?
Yeah, question. Why we did that number 4? We
Huh?
added a square.
Because there is a minus.
Oh, okay.
Going back to that time when we started 5.6. This is sum of squares. We cannot factor this. This particular expression is prime. I dug a nice little trap and everyone just fell in. So, not correct, because a plus b times a minus b applies only if you have a negative. If it is a squared plus b squared, the factor is prime. Good. So we'll just leave it as is.